Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host Shafu, and today's episode, a little different but super interesting, about generative art on-chain. Our guest today is Quaq. Quaq, thanks for taking the time, man.
Yeah, absolutely. Thank you for having me.
For sure. So why don't you very briefly introduce yourself and then share your screen and so we can take a look at the code.
Yeah, absolutely. So yeah, I go by Quaq. I'm a smart contract engineer at Tessera and Escher, and then I'm also kind of on the side working kind of making on-chain art and kind of releasing some kind of fun art projects on the side. So yeah, that's me. And if I guess we'll dive right into it. Let me share my screen here.
Awesome. So yeah, we thought a little bit about how we're going to structure this. I think the best way is to actually show the result, show the art, and then go into the contracts from there.
Absolutely. Let me stop. Great.
Yeah, just disclaimer, there's going to be some JavaScript code today.
Yes. Fortunately, there's some JavaScript. All right. So yes, so here is the project, my first project I did called Zoo of Neural Automata, and these are this is an 1155 addition contract where I basically issue these additions of what are called cellular neural automata, which is kind of it's a very fun kind of computer science kind of thing that I like fell into and got very interested in and wanted to kind of create art around and get the kind of algorithm on chain to make these additions. So yeah, these are them. These are the kind of 7 that are out right now. And so I think it's worth to know kind of what neural cellular automata are and kind of how they work. So like the most basic kind of cellular automata is like Conway's Game of Life. And so you might have seen this. This is a pretty fun kind of simulation that kind of like emulates life in a way. Basically, you have these cells, and depending on how many other cells are alive around them, they may kind of like reproduce or die, and it kind of creates a lot of these kind of interesting interactions like you can see here. So that's the first and kind of most famous cellular automata. But neural cellular automata, the way they work is they use convolution and to progress. So like convolution is something that's used in like computer vision algorithms for machine learning. And so this is something that I used to do research on. So instead of kind of having basic logical rules, you apply like a convolution filter. So you basically have a filter that multiplies everything around a cell by this filter, adds it all up, and then you pass it through some kind of like activation function that could be like a sinusoidal function or like a tangent function or really anything. And so that's kind of the way they work. This is kind of a fun one that kind of looks like fire. And as you can see, it progresses in a much more kind of almost a way that looks maybe like a little bit more natural or something like that. So yeah, so they're super fun. This is
Quaq, let's take a step back for a second because you already said some very interesting stuff.
Yeah.
So first of all, why is cellular automata very interesting? I think popularized by Stephen Wolfram, super interesting guy. And the main takeaway of cellular automata is, so for me personally, is like from very simple rules, endless complexity, right?
Exactly. Absolutely.
Which is awesome. The second thing, the convolution, I also have a machine learning background, so that's also interesting. Really interesting for me to see how that is used, right? The convolution operation here. And the third thing is, I didn't even know that this was interactive. So, so that's awesome. That's really cool.
On OpenSea, if you hit space on it, it'll change into like the draw mode, and you can kind of drag around and kind of play with it. I think if you press Z, it'll also pause, and so you can kind of get your kind of draw fun shapes on there and all that. So yeah.
That's really cool. Awesome. Okay, where should we head next? Contracts?
Yeah, I think we could head to the contracts, and I'll kind of maybe start with where I kind of started with the contracts. Does that sound good?
Awesome.
Cool. Let's do it. Great. So where I kind of started with the contracts was with the token contract, just because I knew I wanted this to be an 1155 token, and so I was like, all right, this is the kind of best place to start. So I guess the way I kind of start these contracts is
Yeah, if you can zoom in a little bit.
zoom in. Yeah, here. Is this good?
Looks good. Looks good.
Perfect. Great. Yeah. So like the way I kind of start with these contracts is I guess I just, got 1155 from Soulmate, and then kind of started the contract off. And so this is a really simple 1155 contract. I have like the name and the symbol, and then a kind of contract level URI that I set through like a permission function. The contract's like ownable, owned by me, so that I can kind of like make updates and like issue new tokens, add tokens in the future. And I'll kind of get into how that works a little bit. So basically, each of these tokens has a bunch of parameters that define kind of how it works in the kind of neural cellular automata simulation. And so there's a struct of those params, which I'll maybe kind of get into a little bit later on like the engine contract and how they work. But basically for each token, I just store like those parameters for the art. I store an address of a token minter, an address of a token burner, a base URI of the token, and then a Boolean value for if the token's frozen or not. And so basically, like what this allows me to do is anytime I want to issue a new token, I don't have to issue it in the same way as the last one. I can just make a kind of sale contract that could be like a fixed price sale or an auction or like something weird like a VRGDA, and like write that sale contract and basically just give it permission to mint an ID of a token. And the same thing with like the burner contract. So if I ever want to issue, like have tokens be burned for another one, I can also like write the logic for that, and so set a like burner contract. And so that just gives me a lot of kind of control over like each of the token IDs and kind of how they can be issued and kind of burned and all that kind of stuff. And then also, I do have that fine level of control, but when you're thinking about like on-chain art and kind of like the permanence of art, you also like don't want one person to be able to like always kind of change those things. So I also add in like an ability for me to like freeze my own ability to do that. So I can actually like, freeze the token, make sure that its parameters and, minter burner contract can't be updated so that it's really set on the contract forever. But yeah, any questions there?
No, it would be really interesting for me to look at the parameters, but let's go
Yeah,
through the contract first.
Yeah, absolutely. So yeah, it's really basic. Like I just basically give myself the function to like make a new token where I can set all of these parameters. I can update the parameters, minter, burner, base URI of like an individual token with these functions. I can only call this if it's unfrozen, like for an ID. So if I decide to freeze an ID, I'll never be able to kind of change those things. Then there's the kind of engine contract, which is where the kind of art is stored and the art gets generated. And so I give myself ability to kind of update this in the future, just in the case that like I kind of want to add something on top of it. And then, the mint and burn functions basically just requires that the message sender is the like address that's set as the minter of that ID. And then it just mints it, kind of as you would just to whoever an amount. Same thing with burn. And then, the URI function, little funky here, but basically we require that the minter of the ID isn't 0, just kind of requiring that the ID like exists, because kind of figure that for it to exist, like a minter kind of sale contract has to have been set. And then we Yeah, just base 64 encode the result of this engine contract, and I can get into that if you'd like, or if you have any questions.
Yeah, it would be interesting to jump into the engine, I think, next.
Yeah, take a look at that. So yeah, this is definitely the one that's a bit more interesting. I'd say. So this is the way that I was able to get everything on chain and achieve achieve all this was with the help of ETHFS, or Ethereum file system. So yeah, the first thing I import is this kind of iFile store, which is an interface for ETHFS. I need base 64 to base 64 encode a lot of these strings, and then I also have this NCA params struct, which it's in the interface contract, but basically it contains a few kind of parameters that are relevant to the JavaScript file. So there's the seed, and so the seed is the seed that gets set, the random seed that gets set. So every time you click on one of these, for example, it'll have it'll kind of pseudo randomly populate, and so I just have it to where we set the seed for that at the beginning. It's typically 0, or maybe I'll kind of make it 1 or 2 if I like the way that the base state looks a little bit better. But so yeah, you can see that it's set here. We also set a background color. So in this case, here, it's black, so the background color is black. And then I also give myself 2 foreground colors. So on this one, for example, the background's kind of this kind of off-white color, but then the foreground colors are yellow and gray. And so basically every cell, instead of having a 0 or a 1 value, it'll be a value between 0 and 1. And so I can just basically, it just creates a gradient between the 2 foreground colors based on the kind of intensity of the cell. And so, that just kind of gives me control over the kind of color palette of the art. We have the matrix, which is the kind of most important part of the art. This is the convolution matrix. Here, these are kind of found by just kind of playing around with the algorithm, giving it kind of random values. These are very important to how it progresses, as this is the kind of convolution filter that's applied over all the cells. And then the other very important function is the activation function. So once convolution is performed, or everything's multiplied and summed up, it gets passed through the activation function. So this is another very important part to kind of how the art looks, how the simulation behaves. And so I basically pass in all those parameters as strings. It's also, so the other thing is the random function. I forget about that sometimes. It's basically just the logic that goes inside of the random function. There's cases where most of the time you want it to be a number between 0 and 1, but there's some cases where you actually want it to be a lot higher. For the example of the Conways, this is kind of an interesting case where you're kind of tricking the cellular neural automata into just being kind of a basic cellular automata. So I needed to give myself a little bit more control over how randomness is decided inside the script. And then there's actually one more parameter, which is mods. And so you can actually see that here, the params.mod. Basically, when we put the whole script together, we append all these parameters with the base script, and then we'll also at the end append whatever string is in the kind of mods slot. And basically what that allows us to do is just overwrite code or add code in the future to the script. So it just kind of gives a higher level of control in the future. But yeah.
That's really cool. If you can scroll up to the initialization again. It's pretty cool because what you pass in is basically executable JavaScript code as a string, right?
Exactly. Yeah.
This is really cool, and of course it's super flexible. You can do anything you want in there. which is pretty awesome. And maybe for the convolution, again, for those that don't know what a convolution does, I would recommend watch a YouTube video or something, but a convolution goes over the image and convolves the image. I think that's the right term here. And the matrix here are the elements that you do the convolution with. Yeah, it's can you once again describe how you came up with the elements in the matrix? Was it just playing around and
It's a lot of playing around. So there is, I got the inspiration for this project from this website called neuralpatterns.io. And there's the guy who made this has a great YouTube video, which I can maybe find the link for in a bit. But I think kind of playing around on here and trying to find kind of interesting kind of patterns or kind of unique patterns that I like is kind of helpful for kind of creating new ones and then tweaking them a little bit, yeah, there's, as you can see, there's like lots of really fun kind of patterns that you can get out of here just by like randomizing. Playing with the activation function is also like super helpful. It's cool because you can kind of go in here and like, kind of like just like change this activation function, change the code a little bit, kind of see kind of like how like, adding certain numbers or adding different functions can kind of change the way that things look. But yeah, this is how I find like most of the art, just kind of going on this website. And yeah, I basically found this and then kind of rewrote the code in JavaScript so that I was able to store it on chain and have it like directly kind of rendered and interpreted by the browser. Yeah.
Awesome. Okay, but I think there's still some interesting stuff in this contract here.
Yes.
Okay, so we did the initialization.
This is a really important part here. So this kind of file store that I mentioned earlier, that's a part of ETHFS or Ethereum File System. It basically, we store this, and this is the file store is the kind of ETHFS contract that we need. I pass it in for the purpose of like, there's a different address on testnet and on mainnet.
Can you describe what ETHFS is exactly? Because that's the first time I actually hear about it.
Yeah, absolutely. So ETHFS is called like the Ethereum file system, and basically the way it works is it uses SStore2 to basically upload kind of arbitrary files as like base64 encoded like plain text on chain. And it also kind of is like a way to kind of, for like larger files, a way to kind of like organize those. So like, for example, like P5.js is like stored entirely on chain here and in like a kind of minified, kind of compressed version. And so it's really interesting. So this is actually stored across, I think, 12 different contracts because P5.js is a pretty large library. And so people basically, figured out that they basically offered bounties to where they said, if you upload kind of one kind of 12 pieces of the thing, we can all get it up there. And so now like P5.js is like on chain permanently through ETHFS, which is great. And so it's super easy to like use this. You basically like kind of like how I have in my contract define the file store with like the kind of file store contract, like where it's at. And then if you want to use ETHFS, you can read it. You call file store get file with the name of the file, and then you kind of read that file. And then, basically what this will do is it'll just return the entire P5.js library as like a base64 encoded string. And so that's how I use it in my contracts here. We like read it from the file store, append it inside like a script tag. And so this helps us create a full HTML page like for the NFT.
Yeah. This is really cool.
Yeah, it's an amazing tool, and it's like an amazing step kind of in the kind of like on-chain art space. And so it's been very, 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 very fun to play around with. When I saw that it came out and people were able to upload P5.js on chain, I definitely wanted to kind of make something with it and get it out there. So that's
Yeah.
what I did. Yeah,
The only thing is it sounds expensive gas-wise,
it
to store
is.
all of that on chain.
Yeah,
But yeah.
I think, and I think that's why they kind of split it up. Is I think they uploaded it in 12 chunks, and I think each chunk probably costs like zero point 0.3 or zero point 0.4 ETH to get on
Oh,
there. So it definitely costed, couple, couple maybe a few ETH to get it all up in chain. So we definitely appreciate all the people that were, kind of uploaded chunks for the kind of public good. So that was awesome. But, yeah.
that's cool. Okay, so the P5 function, creates this HTML page. Then we have the script function next. This,
Yeah. This builds the script basically with the parameters, that we want. So given these kind of NCA parameters, it'll just concatenate those with like the rest of the script, which is basically like, these are basically kind of like parts of the parameters that are passed in. And then it'll put that all together with the rest of the code down here for like, like doing the convolution and like the controls to pause and switch to draw mode and all that. So it'll add those, and then it'll also add the kind of optional mods, which is just kind of like extra code that you might want to add on to the script at the end. Appends those all together. Base64 encodes it inside of a script tag, and then you can put that along with your P5.js script tag up here. I think it's important to note like this other kind of script is this version of P5 is compressed using I guess Gunzip, and so this script here is basically just kind of uncompressing it so that it can be used. So you basically have these three scripts which get put together down here for like the page, which is like the entire HTML page, and so I define some kind of basic HTML tags up here with some CSS just to basically center everything. And then you put the P5 script in, the Neural Automata script in, and then just close off those HTML tags. And then that whole thing gets base64 encoded into the page. And then once you go back, that gets put into a JSON with all the other, like the name and the description, and then that gets base64 encoded again. So it's definitely, it's like 3 levels of base64 encoding, but so it's a lot of just random characters. But
yeah, but the result is awesome. This is 100% on chain.
It's this whole script is stored entirely on chain. So like this whole thing here where you can randomize it and draw on it and all that is stored entirely on Ethereum, kind of forever, which I think is pretty fun. But and actually, if you want one of these, the Conways, which is the kind of first one I did, these are actually free and they're free forever. So if you go to like Zona.wgf and you go to the bottom here, you can mint one of these for free. It's like one per wallet. And so I just want to do that just so everyone's able to kind of have one and have one to play around with. But yeah.
No, that's awesome.
Yep.
Okay, so let's look at the different. So you would have different minter contracts, right?
That's correct. Yeah. So I've got several different kind of like sales contracts. So like these are kind of like proxy, I guess, contracts that are able to like mint the token like on behalf of that actual token contract and kind of either sell it or issue it like a specific ID for free. And so like Like these can range from like very simple to like more complicated. So like the Conway's one is very simple. We just basically store the Zona address, which is like the address of the token, the start time of the sale. We have a mapping from like address to a Boolean value just to see if an address has actually like claimed one yet. Set all those parameters, set myself as the owner, and then for the mint function, we basically we're going to require that we're kind of at the start time. We're going to require that or that the message sender equals the owner. This basically just allowed me to mint one before it started, just so I could kind of like, see it on OpenSea and like share the link on OpenSea. And otherwise, we just require that you haven't claimed one yet, set that claim is true, and then that way we don't get a little reentrancy bug in here. And then, just basically tell the Zona contract to mint it to ID 0, one of ID 0 to that person. So,
Okay, so you have a minter contract for each different, what would you call it, version? What is the right term here?
I guess each ID or each edition has its own minter contract.
Okay, edition.
Yeah, each edition has its own minter contract. So like the Oshun's one for edition, this was actually an auction contract. So like instead of having a mint function, we have like a bid function and like functions to like settle the auction and all that. So it allows just to have like different kind of sale mechanisms for each ID. Then like the Infernus like one for edition, this one you actually have to burn one of the quacks to get it. So for this one, I actually set this as the minter of an ID of like the Infernus ID, and then the burner of like another ID. So it's able to burn a token and mint one, like as you can kind of see here. Yeah.
Okay. So just a bit of flexibility here for different sale processes, mint processes, or whatever you want to call it, right?
Absolutely.
That's cool. Before we jump into the JavaScript code, and that's actually really interesting to me because I really don't know how this works. What is the OpenSea interface to? So how I imagine this works is you have a view function, right? And your contract, OpenSea calls that somehow, gets the whole JavaScript file and renders that.
Yes.
What is the specific interface here?
So the function that like OpenSea would be calling is this like URI function for an ID. And so, one thing that is actually pretty interesting is that you can actually kind of set like two kind of images or two kind of like media files for an NFT. You can set like the image tag, and you can also set the animated URL tag. And so the art for this that's actually stored on chain is in this animated URL tag. And so the basically like when you go here, what you're seeing is like the image tag. So this is kind of just like a placeholder kind of GIF. So this actually isn't like running the simulation. But like when you click in and you're looking at the animated URL tag, this is the part that's actually like stored on chain. And so there actually are kind of like two different kind of images that OpenSea like parses from your like entire like metadata JSON. And basically the way that I deal with that is I just like upload the kind of like basic like the name, the description, and things like that into like the kind of tokens based URI. And then for the animated URL, that's where I'm kind of calling the Neural Automata engine contract to get the whole like HTML page that's base 64 encoded.
Okay, so the GIF you would need to create yourself.
Yeah.
Okay, I see.
Yeah.
Awesome.
Yeah.
Should we take a look at the JavaScript code?
Yeah, we can definitely take a look through it. So like, yeah, this is an example of one of them. I think these are called sun drops. But yeah, so basically the way that I'm just going to turn it off just so it's not as laggy. But yeah, basically like the way it works, I actually haven't looked at this in a while, but yeah, we're basically just defining like a two-dimensional like array, which is like the grid of all of our values. So it's like I think it's like 100 by 100 grid maybe for like each of these cells. And then to kind of start, we like set the background as our background color, generate this function. I believe just populates it with the next set of values. And so like we start with random values and we perform our kind of convolution to get the next set of values. So I'll kind of like maybe like kind of see if I can kind of like pause and like show how that works. So like here would be like, let me see if I can get it to run for a little bit. Yeah, so like basically it's going to start with kind of like random values. So it's going to go through and it's going to make all of these squares a value between 0 and 1. So like if it's closer to 0, it's going to be more gray. If it's closer to 1, it's going to be more yellow. And then what it's going to do for each of these squares for like the convolution, what it does is it goes over each one of these kind of squares on the grid. It's going to look at the 8 values around it. It's going to basically multiply all those values by the convolution matrix. So like the convolution matrix here is going to multiply the values. So like this one here, like it would basically, these would be like around it would be like, I don't know if you can see my mouse, like these ones around it would be like 0, but then like this one on top of it would maybe be like 0.2 or something. And so it's going to multiply all that by these values, sum them all up, and then it's going to get that number, and then it's going to pass that number as x through the activation function. So whatever sign of that number is going to be the next value of this cell. And so it does that for all of the cells on the grid for like each step. And so it just continues to basically just do that, update it, and then just set it to the next one. And so like once it progresses, you can kind of see that process take place. But yeah, it's really fun. The job, I'm definitely more of a smart contract engineer, so the job is like a little bit messy. It was kind of just kind of like a matter of like getting it to work. After I kind of got that part done, I went and added in some of these kind of like controls for like, when the mouse is kind of like when you click, like it resets the values. When you press space, it turns it into like draw mode, so you can actually go and like kind of draw on it. And then like you can press Z to pause. And so I thought those controls were pretty fun, especially like the draw mode was, I think, pretty important to have. So kind of going through and figuring those parts out. So that's actually a lot of the code is just kind of like the controls and like making sure that you can kind of have those kinds of interactions with it. And then outside of that, that's really about it. Do you have any questions about it?
Yeah, just again, 160 lines of code and look at the result, look at all this complexity. And this is what's really awesome about cellular automata. So I highly recommend anyone to, if you don't know what cellular automators are, take a look at them. It's really, really interesting from a computer science perspective.
Absolutely, yeah. And I've got a video that I can share with you, maybe like for the description of the video. Like if people want to go watch that, I think is like probably does a much better job at explaining them than me. But yeah, they're super fun, and it is amazing like how much complexity can come from basically just like a 3x3 like matrix of values and like an activation function. So super fun.
Yeah, well, what's also interesting is from a DevOps perspective, this your iteration speed is super quick, right? P5JS, what you're using here is, where you write JavaScript and immediately see the results. You do your experiments and then put in the parameters and deploy that, right?
Right, yeah, and I wanted to kind of really just set it up for myself to like really just give myself kind of like a fine level of kind of control, kind of like moving, so that it's like if I want to make like a new addition for kind of whatever reason, like if it's like kind of relevant at the time, like I kind of move fast on it and like find one that's kind of that like looks fun and like just write a little sale contract and get it out there. So, yeah.
Awesome. Quaq, this was really cool, really interesting. If people want to find you, where's the best place?
Yeah, Twitter, definitely. It's quaq.eth. My handle is at 0x0AA0. And so, yeah, that's me on Twitter. Yeah, follow me there. I provide like updates on this project and some other kind of art projects I've been working on there. And so, yeah, that's the best place to find me.
Awesome. Quaq's Twitter, OpenSea, his website, all in the description. Thank you, man, for taking the time.
Yeah, thank you so much for having me. It's very fun. It's fun to talk about and kind of dive in and yeah, take a look at it again. It's very fun.
For sure. Hopefully, episode number 2 with Quaq very soon. If you have something interesting to show like this, definitely have you on again.
Yeah, absolutely. No, I think I've got one coming up that would be very fun to dive into. So yeah, I'd love to be back. Yeah.
Awesome. Okay, man. Then thanks guys, and see you in the next one. Bye.